Hello and welcome to a lesson on error detection and correction. So before we go into those main concepts, I just have to give you an introduction of what is error. Error is basically a mistake. When the data is sent, the data may not be received properly at the other end, and it is called as an error. Now there are few types of errors, and it's basically because there is some kind of a loss during the transmission, or when some other data gets added during the transmission. That is called as noise, when another data gets added. And when you lose some data, of course it's called as a loss in the signal. It happens due to various reasons, such as the cable being loose, or cable gets broken, or there is some problem with the cable, such as the wires are exposed so that the outside signal gets caught onto it and it becomes a noise. Our goal is to find out if the data received has an error, and if possible, how to correct it. So obviously there is just one easy way to correct it, that is to ask the sender to send the data again. So we are going to learn 6 of them. First one is checksum, second is check digit, third is parity check, fourth is echo check, fifth is automatic repeat request, and sixth is cyclic redundancy check. Okay, don't get worried with the different terminologies. These are all pretty simple and easy to understand. Once you understand this, you'll be able to write the definition by yourself quite easily. Okay, the first definition is for checksum. As the word says, it is a sum to check whether the data is received properly. So as we know, data is being sent as blocks. Okay, data is like, for example, if you want to receive a huge file like a video from Netflix or YouTube, it's not being received as one file, just like how you copy to your pen drive, or transfer from your phone to your computer, or from computer to your phone through a cable, or you transfer between phones through Zapier. There are many methods to do it, but it's not just sent as one drop, right? The data gets sent one after the other, like it's a bulk of data that's being sent as tiny parts. So checksum is one part of that data which is sent along with the full thing, and the receiver will receive that, and it's already decided and agreed upon that either it is the last block, which is the checksum, or it is the first block, which is the checksum. So the receiver will check the value of the checksum, and the algorithm or the method of calculation will already be agreed upon. Like add all the numbers and multiply by 2 and you get the checksum. Let's just say checksum is 100. So we know that the sum of all the numbers times 2 should be 100. If that is not 100, you know that the data is not validly received. I hope that is easy to follow in that way. Then the next one is the parity check. This is when the data is sent basically as binary, when we'll check the number of 1. Okay, like you just count the number of ones. In case of an even parity which is agreed by the sender and receiver, if the number of ones are even, which means the data is accepted. And in the case of an odd parity, if the number of ones in the data is odd, it means that the data is accepted. Otherwise the data is rejected and you'd have to send the data again, like if there is some mistake in there. So if there are many bytes of data being sent, there will be another separate byte called as the parity byte, with which we can check if the data is valid or not. Okay, next third one is called as echo check, where data is being sent from the sender to the receiver, and the receiver sends it back to the sender also. So when the receiver's data which is sent back can be compared by the sender to check if there is any mistake or not. Like for example, if I'm sending you a message like say hi, HI, and I'm asking you to send it back to me, and if you send just H back to me, I know that there is a mistake, right? Because I know that I've sent it hi, so I'm expecting the hi to come back. That is the kind of echo checking, sending the data to you and getting it back and comparing it. If there is an error in that situation, the sender will send it again. So until the echo or the reply is the same, we'll be sending the data again and again. And the next is check digit. Check digit is like a digit, like it could be the first or the last or a specific position which is already agreed upon. Like it's used to find out whether there is 4 types of mistakes. So you can find the check digit by calculating the other digits. 4 types of errors are incorrect, transposed, omitted, and phonetic error. Now incorrect data is when you send something entirely wrong. Instead of just 250, you have sent 260, which is wrong in this case. And the next one is transposed data. Transposed data is when the position of the data is messed up. Like for example, 250 has been sent as 205. Then there is the omitted data, when there is a part of the data which is not being sent. For example, if 200 was to be sent by the sender and the receiver got it as only 20, that's a mistake, right? That is the omitted data. The next one is the phonetic error. Phonetic error is like the mistake which happens when you type out the numbers due to the pronunciation, like you say 30 for 30, but the data which was typed was 13 and 13 was being sent. So that's the small mistake there, right? So these kind of mistakes can be found out that there was a mistake. That's the only thing which you can find, and most of the time it will be required to resend the data from the sender to the receiver to check whether the data has been received properly or not. The book barcodes use these check digits. So we have been seeing a lot of check digit questions in our past papers, so we'll be trying to solve one check digit question. The next one is automatic repeat requests. Although it is automatic repeat request, the short form becomes ARQ. Alright, so this is a method in which the sender will send the data and the receiver will send an acknowledgement, somewhat like our blue ticks. So when the receiver sends the acknowledgement back, the sender knows that the data has been received. Now here, the receiver sends a positive or a negative acknowledgement as necessary. So like the sender sends the data, and if the data is received correctly, the receiver sends a positive acknowledgement. And if the data is received incorrectly, the receiver will send a negative acknowledgement. So it's as simple as that. And the sender has a timeout, like maybe like 120 seconds or like 100 milliseconds. It depends on the situation and the distance and the type of program which is used for the data transmission. All right, it's quite like you send the data and wait for the reply. Once you get the positive reply, that's it, the data is transmitted. If you get a negative reply, you can send the data again, and until you get a positive reply, you keep repeating this. That is automatic repeat request. And the last one is cyclic redundancy check, or CRC. As we told before, data is being sent as blocks, right? So, and these blocks are called as packets. Each packet will have a header, a payload, and a trailer. Header is your starting part, payload is the main data, and the trailer is the ending part. Okay, the header will contain the sender's details and the receiver's details along with the packet size, like so and so bytes, kilobytes, and also a serial number or a sequence number, something like that. Then the payload is where the actual data is being sent, and the last one, the trailer, will have the unique identification to differentiate between other packets. And usually the packet trailer uses the checksum or check digit to check for error. So the 6 concepts that we learned today are checksum, check digit, parity check, echo check, automatic repeat request, and cyclic redundancy check. 6 of them, out of which check digit or checksum and the parity have been asked in lots of past papers. So please have a go through this assignment question and try to do it. I hope our concept is clear. Thank you very much. So we're going to check out how to solve a check digit question. On the assignment question which is there, a company selling books uses a unique 6-digit identification number for each title. The rightmost digit is position 1, that is a check digit. Now its example is also given there. 54321, that is a digit position, and below that is 65373. So the number 65373 is being sent, and the digit positions are mentioned there, one being the rightmost, and that is the check digit. Now the rule for the check digit is that the validity of the number and check digit is calculated as follows: multiply each digit by its digit position, add up the results of the multiplications, and divide the answer by 10. That is the value of the check digit. Now we have to check whether these are valid or invalid. The first one, the identification number, is 45238. So I'm just going to write that one down, 45238. Since this question requires the working to be given, so we're going to write the digit positions also in the space given, and then do the calculation there and find the results. So digit position comes from 1, 2, 3, 4, 5. So each you have to just multiply them and find the value as 1 times 8 is 8, 2 times 3 is 6, 3 times 2 is 6, 4 times 5 is 20, 5 times 4 is 20, and then you add them up. So don't worry even if you do not have a calculator, and sometimes mental math is very helpful, but otherwise you can just do it kind of easily. Like we have 6 plus 6 is 12, 12 plus 8 becomes a 20 here. Again 3 20s are there, so that's 3 times 2 with a 0 becomes 60. So we have 60, and the next step is 60 divided by 10, which is equal to 6. So in that case, if the last digit is that 6, it is valid, right? But the last digit here is 8. It is a position 1 as given in the question. So we are going to check that one, and that is not 6, which means this data is invalid. Okay, now let's look at the second part of that one. There is a B part which asks, find the check digit for this identification number. To find the check digit for this identification number, the number given is 5032 and a dash. Okay, this is although it looks pretty complicated to find the last digit, it's quite easy. We just have to follow the same rules there. We could write the position number. You start with the one with the dash, 1, 2, 3, 4, and 5. The step is the same. You have to multiply and add them up. So 5 times 5 is 25, plus 4 times 0 is 0, 3 times 3 is 9, 2 times 2 is 4, and the last one we're just going to put it as x. So x times 1 is x. All right. So yeah, we have math and algebra coming up, but still it doesn't get as complicated as it sounds. Let's take a look. So 25, then 9 and 4. 9 plus 4 is 13, plus 25 becomes like 38, I believe. Plus x is our the sum as we have got before. This is 38 plus x. We know that it is a product of 10 because whatever it's divided by 10 will give you the check digit, right? So the nearest number which can be divided by 10 is, of course, for 38 it's going to be 40. It's not going to be 30 because x is not going to be a negative number here. So we're going to assume that it is 40. So we'll just say 40 by 10 is like the value. So it becomes, so you can just assume the x is 2 here, right? So you have found it, and that's not the end of the question's answer yet. You have to write it as the identification number. 50322 is the identification number, and that's how you conclude that question. The concept that requires a little bit explanation with the help of the bits and bytes is the parity. So we have two types of parity checks. First, let's just take a look at this value and then see how it is. Okay, so a byte, as you know, is having 8 bits. Bit is each digit, right? 1 or 0. So 8 of them. So I'm just going to put 1010 1101. Okay, these are just 8 digits there. So I'm going to assume that first digit is the parity byte. First digit in the sense I'll be counting from here, right? So this is the parity bit. Okay. Now in case if we are using an even parity, okay, an even parity, in that case the total number of ones should be even. Now let's just count it. So we have 1, 2, 3, 4 and 5. 5 ones, which is not even. So in this case data is invalid. Simple as that. Just count the number of ones. If it is even, then it is follows the even parity and the data is valid. But here we got 5 ones which is not even, and data becomes invalid. Now the question is, how would you know whether it is even or odd? Obviously it will be given in the question that this data follows even parity or odd parity. When I was setting up a sender and a receiver for communication, they always agree what type of error checking is followed. So for even parity, this is the one, and let's look at odd parity. 1 0 1 0 1 0 0 0. Okay, now you can see that the last one, I'm just assuming it as the parity bit, okay, because the question can always define where the parity bit is. You just have to read it carefully and check where the parity bit is. All right, the last one is the parity bit in this case, and we're going to count the number of ones, 1 2 and 3. 3, which is odd, so which means this data is valid. Okay, so that's about even and odd parity, and also the check digit. And checksum and check digit are somewhat related, and then there is automatic repeat request, ARQ or cyclic redundancy check, CRC, echo check. All right, so I hope we have concluded all the topics. Thank you. Bye.